In this experiment, we're going to be using titrations to determine the concentration of vinegar in a solution. A solution of vinegar is composed of two ingredients or two components. We have the solute, which is acetic acid, and then the solvent, which is water. So in a solution, there are two components, the solvent and the solute. And in vinegar, the solute is acetic acid. The formula for acetic acid, it's right there. It's your acetate ion combined with a proton, which is a hydrogen atom with a positive charge. So I have my proton in red. The proton is what makes the compound acetic acid acidic. Commercial vinegar has a concentration close to 5% by mass. So we're going to do the titration to determine exactly what percent of a solution is your solute, which is vinegar. The equation for mass percent, I'm showing you here for the actual solution. If a solution is 5% percent by mass, it means that you have 5 grams of your solute, in this case the acetic acid, in every 100 grams of the solution. 5 divided by 100 times 100, that will give you 5%. Over here, you have the actual reaction of the experiment for today. You have sodium hydroxide plus vinegar, which is acetic acid molecule right here. And your product is water and sodium acetate. Those are the products for the reaction. So sodium hydroxide is a base. You have the hydroxide ion in red. When sodium hydroxide reacts with acetic acid, the proton from acetic acid and the hydroxide ion, they're going to combine to give you water, H2O. And then you have the sodium ion and the acetate ion. Sodium is +1, acetate is -1. So they're combining to give you sodium acetate. So the stoichiometry from your reaction is telling you 1 mole of sodium hydroxide reacts with 1 mole of acetic acid to form 1 mole of water and 1 mole of sodium acetate. The indicator for this titration is phenolphthalein. Just to review, phenolphthalein is clear when you have a neutral solution and when you have an acidic solution. Phenolphthalein is pink in basic solutions. At the equivalence point of the titration, we have that the moles of sodium hydroxide, which is the base that we're using for the titration, it's equal to the moles of the acetic acid that you have in solution. And that information is what we're going to be using to perform the calculations to find out the concentration of acetic acid in vinegar. From your titration, the end point is what you can observe, which is when the color changes. So we're aiming to get the light pink color again in this titration. So the number of moles of the base are very close or almost exactly the same as the number of moles of the acid present. For the procedure, the first thing that we have to do is to dilute the vinegar sample. The vinegar, if it's something close to 5% by mass, it's too concentrated for the sodium hydroxide solution that we're using. If you want to titrate a sample of vinegar directly, it means that you're going to require a lot of sodium hydroxide in order for you to determine the end point of the titration. So for diluting the vinegar sample, you're going to go to the fume hood and you're going to transfer about 20 milliliters of vinegar in a small beaker. Make sure that the beaker is clean. So from those 10 milliliters of vinegar, you're going to use a pipette to take only 10 milliliters. So it's 20, so you have enough in your beaker to use the pipette to take 10 milliliters. So the amount that you're actually diluting is the 10 milliliters of vinegar. So transfer those 10 milliliters that you're taking with the pipette into a volumetric flask. And now we're going to dilute those 10 milliliters all the way to 50, which is the total volume of your volumetric flask. Remember, when you're preparing your solution, you have to make sure that the distilled water that you're adding to dilute your 10 milliliters of vinegar to 50 in your solution, that you don't pass the calibration line in your volumetric flask. The calibration line is telling you when you go all the way to that line, you have 50 milliliters of your solution. So that's the line that you need to aim for. Don't add too much because you'll have to prepare your solution again. Once you have your 10 milliliters diluted all the way to the line with distilled water, cap your volumetric flask and then invert the flask at least 10 times. That's to mix all the vinegar and the water that you're using. Now that diluted solution is the one that we're using to prepare the samples that we're titrating. So from your diluted vinegar solution, transfer some into a beaker because it will be easier for you to use the pipette if you have the solution in a beaker versus the volumetric flask. So transfer some of your solution into a beaker, and now you can use the same pipette, but make sure that you rinse the pipette, and now you can use your pipette to pipette the volumes of your vinegar sample. So take your pipette and measure 10 milliliters using the pipette again from the diluted vinegar solution. Transfer 10 milliliters into each volumetric flask and you have 3 of them. Label your volumetric flask so you can copy the data for each one. So you have in your volumetric and your Ellen Meyer flask, these are Ellen Meyer flask here. You have 3 of them. So 10 milliliters of your diluted vinegar solution into each Ellen Meyer flask. And now you're going to add to each one 40 milliliters of distilled water. So in each volumetric flask, you have your 10 milliliters of your diluted solution that you're measuring using a pipette, and you're going to add 40 milliliters of distilled water, and those 40 milliliters of distilled water you can add using a graduated cylinder. And you need to add to each volumetric flask, each Ellen Meyer flask, 3 drops of phenolphthalein. So in each sample that you have 10 milliliters of your diluted vinegar solution, 40 milliliters of distilled water, and then 3 drops of phenolphthalein.
So for the procedure, the first thing that you have to do is to clean up the burette. Take the burette with you, go to the sink, and you're going to use a little bit of soap. Don't use too much because it's going to take you forever to rinse the soap out of the burette. Add a small
After cleaning the burette and preparing your samples, now you're ready to titrate your samples. So to titrate your samples, you have your burette with the sodium hydroxide. The burette is clamped. Using the burette clamp to a ring stand, put a piece of paper towel under your Erlenmeyer flask, and you can start adding the sodium hydroxide into your sample. So to add the sodium hydroxide into your sample, you're going to add the open the burette and let it go drop by drop into your Erlenmeyer flask with the sample. So drop by drop, patiently waiting for that color change. While you're adding the sodium hydroxide from the burette into the Erlenmeyer flask, make sure that you swirl your Erlenmeyer flask. The paper towel is for you to see the color change. You want a light pink color, so sometimes it's hard for you to see that color if the surface is too dark. So just put the paper towel and make sure that you swirl your sample as the sodium hydroxide goes into the flask. So you need to copy is two experimental data points. In the beginning of your titration, before adding any sodium hydroxide, you have to check how much or what's the volume of sodium hydroxide in your burette. Then you're starting to add your sodium hydroxide, and the sodium hydroxide will go into your Erlenmeyer flask until the color changes. At that point, you're going to close your burette and you're going to copy the final volume, which is the volume at which your sample changes color from clear to pale pink. So for the calculations here, you have your volume of original vinegar in solution. That's when you were pipetting 10 milliliters of your vinegar from the fume hood, and you were diluting those 10 milliliters into your volumetric flask with a total volume of 50. So to find your dilution factor, you're doing your volume diluted, like the total volume that you're using for your dilution, divided by the volume that you're taking for your vinegar, and that will give you your dilution factor. The molarity of the sodium hydroxide that you're using the molarity from your solution that you prepare in experiment 10. In experiment 10, you prepare a solution of sodium hydroxide and you determine the concentration of that solution using a titration with the KHB. So now your concentration, molar concentration for that solution is the one that you're using in this experiment. Now for the volume of your vinegar sample, you're preparing your dilution, and from that solution you're preparing your samples. Your samples, you were taking 10 milliliters from your diluted solution and you were transferring those 10 milliliters into the Erlenmeyer flasks. So that's the volume that you need for your diluted samples. Initial burette reading, that's going to depend on your titrations. The first one, you're filling the burette all the way to 0, but you're using some of that volume for your first titration. So the initial volume for the second one, you need to check what's the volume that you have for sodium hydroxide left in your burette and copy that number. So to find out the volume of the sodium hydroxide that you're using, you have to do the final minus the initial. And that will tell you how much sodium hydroxide you use for your titration. The final burette reading is the one that you're doing when the color is changing from clear to pale pink. So in number 9, you have to actually do a calculation. So I'm showing you down here how to get the most of sodium hydroxide. Molarity, which is the unit of concentration that we're using for the sodium hydroxide, molarity is moles per liters, moles of the solute in every liter for the solution. And remember, the solution contains everything, is the solute and the solvent. So if molarity is moles per liter, it means that you know the volume and you have the concentration. Anytime that you have two out of the three variables in that equation, you can calculate the third one. If you know the volume of sodium hydroxide, which is the volume that you're calculating from your titration, the final volume in your burette minus the initial volume in your burette, that's telling you how much sodium hydroxide you're using for the titration. So you have that volume and you know the concentration of sodium hydroxide because you have that in your table right there for number 4. So molarity is moles per liter, so your number of moles is given by the volume in liters times the molarity. So molarity times your volume in liters is going to tell you how many moles of sodium hydroxide you're using from the burette. From your equation, the balance equation of sodium hydroxide reacting with acetic acid to form the water and the sodium acetate, you know that every mole of sodium hydroxide is going to react with 1 mole of acetic acid. So the molar ratio is 1 to 1. Every mole of sodium hydroxide reacts with 1 mole of acetic acid, which means that the number of moles of acetic acid is the same as the number of moles of sodium hydroxide that you're calculating. For the acetic acid sample, you know the volume, you're using 10 milliliters in your samples, but you don't have a concentration. That's what you're trying to find out. For the sodium hydroxide, you know the volume from your burette and you know the concentration. So for sodium hydroxide, you have 2 out of the 3 things in your molarity equation, which means that you can calculate the moles of sodium hydroxide. Now, the moles of sodium hydroxide is what we need to convert to moles of acetic acid, because to find the concentration of acetic acid, you need to know how many moles of acetic acid you have in your sample. Now, to find out the molarity for your acetic acid, and this is for the diluted sample because you prepared your samples using your diluted solution. So molarity again is moles per liter, the number of moles of your solute, which is acetic acid, in every liter of your solution. So you have your moles of acetic acid because when you calculate the moles of sodium hydroxide, that's the same as the moles of acetic acid. Now the volume for your sample is 10 milliliters. That's the volume that we're using. In the equation for molarity, it's moles per liter, which means that you have to convert your 10 milliliters to liters. And you can calculate the molarity for your diluted sample. The moles of acetic acid divided by your volume of the sample in liters will give you the molarity for your vinegar sample, the diluted one. To find out the molarity for the acetic acid, the original solution, which is the one in the fume hood, the one that you took 10 milliliters and you prepared your diluted solution, diluting those 10 to 50. You just need to multiply the concentration that you're finding in number 11, which is the molarity for the diluted sample, times your dilution factor. If you're diluting this initial sample by a factor, your diluted concentration times that factor will give you the original concentration. So that's what you're doing in number 12. Now, number 13 is for you to actually find out the percent by mass. What we have so far is the concentration, but molar concentration. You want to know the percent by mass. So we're using the molar concentration to find out percent by mass. So you're going to start with the concentration that you have for your original solution. That's what I have here. It's your molarity for the original solution. Now molarity is moles per liters. So you see I'm writing here moles per liter, but you need a number right there. that number is the number that you have in number 12. Now, first thing that I'm doing here in green, I have the molar mass of acetic acid. Your molarity for the original solution is moles of acetic acid per liter. You want to go from those units all the way to grams per grams of your solute per grams of your solution, because that's what you have in your percent by mass equation. So first thing, I'm multiplying my molar concentration, whatever number you have right there, and those are the units, moles per liter, times the molar mass of acetic acid. When you're doing that right there, moles of acetic acid is canceling out. Now you have a number that is in grams of acetic acid per liter of your solution. So the next step, I'm converting my liters to milliliters, and you will see why. So now my volume liters is canceling out with liters. Right now, all the way to 1 liter over 1000 milliliters, what you have is grams of acetic acid in milliliters per milliliters. Next step is multiply that number by the density of your solution. With that last step, you're converting a total volume of solution to grams of solution. That's what we're doing with the density. So your milliliters are going to cancel out. And now the units that you have left are grams here, which are grams of your solute, which is acetic acid, over grams right there, which is grams of the total solution. That number times 100 will give you the percent by mass. And you have your percent by mass in grams of acetic acid, which is your solute, per gram of your solution.